This is Euclid Book 5, proposition number 3. Okay. The official definition reads as follows. If a first magnitude is the same multiple of a second, then the third is of a fourth, and if equal multiples are taken of the first and the third, then the magnitudes taken are also equal multiples respectively, the one of the second and the one of the fourth. Now, if you were to just read that, you'd have no clue as to what was being said there. Okay. All right. What's the first magnitude? Well, it's going to be A right here. If the first magnitude is the same multiple of the second, well, here's the second one right here. This is B right here. So A is the first magnitude and B is the second one right here. All right, as you can see, there are two lengths of B in A. This here is one length of B. This here is the other length of B. So there are two lengths of B in A. All right. Now, what is the third to the fourth? Well, the third one here is C. Okay? C has two lengths of D. In other words, from here to here is one length of D, and here to here is the other length of D. So C has two lengths of D. Okay? Now, EF. EF has two lengths of A. Okay? So from E to K is the same measure of A as K to F. Okay? So E to K measures the same length of A, and K to F measures the same length as A. Now, down here, we have G to L. G to L is the same length as C, and L to H is the same length as C. All right. So what they're saying here is that in line EF is the same number of B as GH is of D. Okay? So you're going to actually find 4 lengths of D in GH, and you're going to find 4 lengths of B in EF. Now, how do we prove this? All right. Now, the first part of the proof says that if EF is the same multiple of A, which it is, okay, that GH is of C, then we're going to say that there are just as many C's in EH, or GH, sorry, there are same number of C's in GH as there are A's in EF. And that's true. There are 2 C's in GH, and there are 2 A's in EF. Follow along so far? Alright, so we're going to divide EF into EK and KF. Okay? And we're going to divide GH into GL and LH. Now remember, GL is the same length as C, and EK is the same length as A. Alright. Now, A is the same multiple of B that C is of D. There are 2 B's in A, and there are 2 D's in C. Now what we're going to do here is we're going to substitute something that's equal. Well, GL is the same length as C. Okay? And EK is the same length as A. So we're going to say that there are just as many B's in EK as there are D's in GL. In other words, you divide GL in half, you'd have G and whatever as one length of D, and L and whatever as one length of D. Okay? So there are 2 D's in GL, and there are 2 A's in EK. Well, there are 2 B's in KF, and there are 2 D's in LH. Okay, let me say that again. There are 2 B's in KF, and there are 2 D's in LH. Okay? So, 2 plus 2 is 4. Okay? So, in the length of EF, there are 4 lengths of B, and in length GH, there are 4 lengths of D. And thus, you have your proof. I will tell you more in a future video, so stay tuned.